where development of young scientists is an attribute of sustainable development of the society. Preparing young researchers for independent scientific activity, the development of intellectual and psychological qualities of a scientist, correlation between the process of thinking and creativity. Phenomena of scientific discovery and genius were always of high interest for psychologists, educators, science historians. Numerous researches were done into specific attributes of a scientist, considering them from different theoretical perspectives. Attempts to identify personal qualities, which are central to the professional activity of a scientist, were made late 19th century in papers by Tearman, Hollingworth, Guilford and others. In the 20th century, classical research by Rowe, Cox Miles, Vlasenko stated that scientific communication, a complex of processes and mechanisms of transmitting scientific ideas inside a scientific community, is an integral part of a scientist's activity. Fast-paced development of modern science and the level of scientific achievements prompted scientists to search for new means of scientific communication. Components of scientific communication as reading scientific papers by other scientists and promoting own scientific concepts can help budding researchers to develop core skills of a scientist and boost their confidence in scientific thinking. The development of information technologies changed the mode of scientific communication. The conventional system based on printing, which relied on a referred scientific journal as a key mechanism for presenting scientific things, underwent transformation and turned into a system, dependent on digital means of transmitting information. Scientometric spaces replaced conventional libraries and publications turned to electronic formats. Communication in science evolves to the process, which counts more on online resources. This transition from printed to digital format changed the roles of all the participants of the scientific communication system. The challenges, prompted by these changes, stay topical nowadays. Behavior and attitude to scientific writing, speaking and presenting things are prior to the intention to pursue academic research career through scientific identity. Introducing the learning environment in scientific communication into educational process ensures developing and improving in young researchers such a skill as undertaking scientific communication, contributes to developing digital competencies and building up an image of a scientist, thus integrating into a single scientific community. The present study is dedicated to developing a comprehensive program of activities concerning scientific communication and compliance with the SCLC model and the principles of Research 2.0. Introduction of the developed program into the process of advanced training of young scientists contributes to improving their skills in scientific communication and confirms their role as a catalyst for developing core skills of young researchers. In the first stage of the program development, with the help of the deductive content analysis of the research papers, dedicated to the models of scientific communication, the authors of this study defined the structure of the program and the key aspects of the content, designed to provide its compliance with the paradigm of Research 2.0. Compared to other models, the scientific communication life cycle model by Björk is more comprehensive, detailed and contains more constituents that reflect activity, findings, elements of governance, mechanisms, etc. When developing the program of activities connected to scientific communication, the SCLC model serves as a roadmap for positioning all the components of the system of scientific collaboration as a global interconnected informational system. The developed comprehensive program consists of 5 stages of different duration from 0.5 to 2 credits. Each of them contains 2 5-inches modules. Stages are creating the information environment, doing the research, presenting the findings, applying the findings and contests for scientists and participation in grant programs. In the second stage, when doing analysis concerning the nature of Research 2.0, were designed a constructive description of activities and projects, as well as actions and strategies which contribute to developing scientific research skills in young scientists and which are based on the principles of openness, collaboration, conversation and connectedness. In the early stage of their activity as scientists, most young specialists have no proper information database on scientific communication, which is explained by the fact that scientific communication is a specific activity, which postgraduate students did not face before. Doing research, modules, which are to define the topic, initiates the research. Review of ideas is the main function of this module. Participants register and create own accounts in the main social networks for scientists. In this module, the participants also create micro-networks with the representatives of a certain scientific school. When the topic is defined, social networking sites for scientists become an additional tool for searching partners for collaboration. Presentation of findings. This stage comprises 5 modules, which are informal communication, presentation of findings through publishing, sharing promotion, tracking and secondary publications. Application of findings. This stage highlights practical skills in transferring scientific knowledge in several directions in parallel, improving the quality of life through its application in industry, IT, healthcare, integration of the knowledge into education and learning, feedback in science. Contests for scientists and participation in grant programs. The global system of scientific communications performs 2 functions. The first is to pass on scientific knowledge, the second is to contribute to decision-making and supporting research from the side of university leadership, business, non-governmental organizations. This stage must be introduced into the program, as lack of understanding concerning the mechanisms of grant participation is a strong communication barrier in the general system of science and innovation support. Participation in contests is not obligatory, but is recommended to all the program participants. The assessment of the program implementation was done with the help of Researcher Development Framework, offered by a world leader in supporting professional development of researchers, the Research and Advisory Centre Vitaliy, Cambridge, United Kingdom. RDF is made of the empiric data, collected through surveying experts in order to identify characteristic features of researchers, defined in RDF as descriptors. Descriptors are structured into 4 domains and 12 subdomains that cover knowledge, intellectual abilities, methods and professional standards of doing a research, as well as personal qualities, knowledge and ability to ensure efficient collaboration with others, and a wider impact of research. The assessment of the results of the program implementation was done through surveying 25 stakeholders, namely heads of scientific schools, leading scientists, who are directly concerned with scientific collaboration with the program participants, university management and business representatives. Every participant of the program was assessed by at least 2 stakeholders through an online surveying. The data concerning changes in the descriptor development or the level of efficiency within the descriptor in the program participants are presented in tables. Fast-paced development of informational environment. Opportunities for researchers to communicate with their colleagues and the whole scientific world via the Internet. In short, new opportunities in strengthening the global system of scientific communication. This fact made it possible for novice researchers to improve their core skills through promoting scientific knowledge, ensuring mechanisms of participation in contests, interaction, collaboration, personal development, and justified the timeliness of developing the program of activities in scientific communication among young scientists, based on the principles of Research 2.0.